Legends on the internet. Let's do this. Legends on the internet. I'm Matt Pat, and today we are learning Simscale. I have a few things that I want to do with it, and I know a little bit about FEA, but there's no quality tutorials around for Simscale, or at least not the paid, not if you're a free subscriber. So this software has like a free tier that lets you use it for 10 simulations with numerical results and 3,000 kind of computer hours total. And so I'm trying to learn how to use it as a free subscriber. The stuff that I'm tooling about with is something that looks a fair bit like a seat post. I do a lot of cycling and so forth, and I'm just trying to get used to how this thing works. I'm a chemical engineer, and so I saw some people doing some CFD in the past. So I kind of understand these concepts around meshing and so forth, where when there's interesting places, you'd want to have more nodes for the calculation to be more accurate, ideally, but at the expense of more compute time. And I'm just trying to understand how to get this thing to calculate. Time and again, I'm getting results that say things like iteration fails, change settings, blah, blah, blah. And I figured I might as well bring you guys along for the journey. And if it turns out the internet finds that interesting, well, maybe it'll be a thing. Maybe not. Right now where I'm at, I can get like a more simple version to kind of solve. And so this is a linear calculation, which I think means there's no real deformation of the part. So it's within its elastic limits. And I'm purposely trying to see what it would take to kind of make these parts fail or deform permanently. And so I've kind of got this thing that looks a bit like a seat tube. There's a slot here, some sort of seat post type thing, just for simplicity at the moment. And I can get that to solve. Let's have a look at its results by calling that linear, i.e. no deformation. Oh gosh, I think I've said the wrong thing. It's clearly deforming. What is it? We can go in here and we can check the settings, and we can find out what does it think the model is. Non-linear, so it is non-linear. So I could get that to solve, and in order to do that, it needed some contact definitions, and in this case I did penalty method, contact stiffness moderate, and defined an interface between those two, and this is highly simple. And I had this as a fixed element. I know that's kind of reverse to a bike, but it doesn't matter really. I'm a bit more interested in seeing how this deforms, so I just made it fixed, and I'm actually applying a force here, and that is the boundary condition. So I've got fixed support remote force and an elastic support. I was previously having it fail because there was no real kind of defined interaction between this part and this part. And so I put in an elastic support here with a K value of 10,000 newtons per meter. I'm not sure if that should be higher or lower. Just trying to get something to solve at the moment, and then I can start fiddling around for independence of that number. And so this did solve. We can have a look at the sort of thing that it'll do. Collapse that down. And so it's got the kind of scaling factor cranked right up to help see what that deformation is. And then across 10 time steps, that changes from 0 force to 100 kilograms applied out here. And so I don't know what number this is meant to be actual. 1 probably makes sense that you're not scaling it at all. And so at time step 0.9 seconds, that's the 9th time step, 100 kilograms, makes sense that this thing would all just kind of bend and open up. That's like a 40 millimeter slot. So then when I come over here, I've been trying to make this a little more complicated, and I've put some sort of a shim in here. Again, I'm not too worried about the geometry. I'm just trying to get the thing to solve at the moment. Learning how to CAD at the same time. I used to watch other people do CFD, so I know kind of how to draw in 3D, and I know kind of how to set these things up, but I've never really done it myself. So this is interesting, and now obviously I'm doing FEA rather than CFD. So we've got the seat post, we've got some sort of shim, we've got a seat tube, and they're kind of standard diameter things, whatever that is, like a standard, I can't remember, 28.2 or whatever it is, and 34.9, common telescoping tube dimensions. I've cut this thing in half, which you can do from the geometry. So you can, so if I choose the parent geometry and I go edit a copy, and there's like, ultimately I want to see what a seat clamp does. And so I've got this basic sort of seat clamp here. And in here, essentially you can half the compute time by splitting the model in a way that it's symmetric. And so mine's symmetric on the x-axis. And we can click apply on that. Oops, I need to select all those bodies. Frustratingly, Simscale has the inverse zoom function to Onshape. And so by cutting this in half and modeling that, we save half the compute time theoretically. I don't know how it actually plays out in the machine, but all of the material that sat out here just isn't calculated now. So that hopefully will speed up calculations. And it makes no difference to our results. And in order to set that up, you can set a boundary condition that says this is symmetric, and the computer knows what to do with it. The other thing that I'm just starting to experiment with is I was trying to improve the mesh on the interfacing faces. And in order to do that, there's something called imprint. And in here, that allows us to say, well, that volume and that volume and that volume and that volume and that one all contact one another. And it creates a section of surface without changing the part. It creates a section of surface that hopefully I'll be able to go and mesh at a higher or finer tolerance. I'm going to cancel this because I've kind of pre-prepared this. There's my geometry there. Telescoping tubes, half copy with an imprint. And I'm going to go down here. We'll have a look at this geometry which has failed. Oh, actually, what we'll do, not this geometry, let's have a look at the mesh. So the mesh I had was this, and I started increasing the mesh density, and it's come up with 4.5 million nodes by, what did I do? Did some local element refinement with a maximum edge size of 2 millimeters. So I haven't generated this mesh yet. When I saw that it was going to be 4 million nodes, I decided that's probably pretty insane. Let's go back and imprint the part. So right now, let's see if we can do that. So I'm going to make sure that I've got the right model. I think it would be this. And hopefully, oh God. Turn off the shim for a second. I can't see any lines corresponding with imprints. Oh, the controls are reversed on this, and it is such a pain in the ass. If for some reason Simscale you can improve that, God, it'd make my life easier. Let's go back up here to our geometries. Assembly, FEA test half. Okay, so I haven't committed this model yet, and I'll just show you. If I remove the shim, for example, my final imprint is actually creating this bit of interface. And would see the same sort of thing here where the shim touches the seat post. And on this one, I'm not going to bother with the seat post clamp. So we are going to press save. And we'll call that half imprint. Down in our geometry here. I've created a new simulation for it. Oh, sorry, that's withering. So I'm not going to simulate it in there. I'm going to simulate it in this one. Tube set, non-linear, and no ring. Let's change the geometry. There we go. And we should be able to turn off the shim and see our imprints exist, and they do. That's good. So we're happy with that. We've got no basic contacts. Here's our physical contacts. It asks us if we want to keep our existing contacts or remove existing contacts. I'm going to keep them. I don't know that it maps them particularly effectively. You can see the software has automatically created 2 contacts, which I don't want. So we'll delete those. And we will specify our physical contact. We're going to have a physical contact. So the way that I've been doing this is I'm calling the seat post the master. It's the fixed bit. I know that's backwards to a bicycle, but in my mind it makes some amount of sense that I don't want it to form. I want it to deform. I want to see how this deforms. So I'm just holding the seat post fixed and bending the seat tube, which makes the seat post the master. Turn off the seat post, turn on the shim. The slave becomes the shim's interface. And then we'll define this physical contact, where we go from the shim's exterior to the seat tube's, oh golly, slave is that, and shim's the master. Okay. No connectors. We'll just apply some materials to this stuff. For fun, I'm calling this a titanium bike frame. We'll call the shim aluminium. And I don't know if it makes any difference, but I've been calling the seat post steel because I'm not interested in how it deforms. I'm more interested in how these parts deform. And our boundary conditions. So we've got a fixed support with the seat post. We have a remote force We'll call it at timestamp half. Because I've now halved the model, I'm going to have to halve the force. And the timestamp, I'm just reducing the number of simulations to try and get it to pump out faster. So 500 newtons is about 50 kilos. And I've got that applying in the Y direction, which flexes it kind of not sideways, but lengthways, causing this slot to open up. So our remote force looks pretty good. And I'm just going to make sure that it is applied in the right location. Well, I'm happy with the location. It's like at the center of the thing, right out at near its end. I don't actually care that much. I think it's possible to choose an edge, but that seems fine. And from the table we saw that's in the Y direction. Oh, actually, does it need an edge? It seems happier now. Yeah, it doesn't seem to have moved it, so I don't know why that face needs to be selected. Elastic support. So this was failing before because as a deformable interaction, I could see that, like, it makes sense that these interact, but I wasn't telling the computer how to make them interact. And so it told me that it needed an elastic support, otherwise it wasn't going to solve. And right now we will redefine those. So let's get rid of the seat post for a moment, and we will interact that with the seat post outer. I have no idea if 10,000 newtons per meter is appropriate. Love to just get it to solve. So we just did seat post to shim. Now we are interested in doing shim outer to the seat tube inner. I have no idea what a stiffness definition is. And our symmetry. I think I called this symmetry, but what we're doing here in Simscale, we're calling this a fixed value boundary condition. And that says that all of these faces can't deform in the X direction. So I rotate this around. It won't deform in this direction, so there's no bending that way, but it can deform in the Y direction, which is where we're applying the force, and it can deform in Z. I don't know if we want it to deform in Z. I mean, fundamentally, I can't see a reason that it would deform in the Z direction, but we'll see what happens. All right, let's have a look at our mesh. And let's create some local element refinements based on let's turn off the seat post and turn off the shim for a moment. Let's refine that. Let's refine the outside and inside of the shim. And let's refine the outside of the seat post. And we'll make that quite fine, because I think that could be why it's failing. Simulation control will run for half a second of interval time. I think let's go 0.25 of a second. So we'll see if it can like solve at 2 time steps. That should give us 0, half force, and full force. We've got a maximum runtime of 10,000 seconds. I don't really know what any of these other numbers are doing. Save that. And let's send that off for calculation. There we go, start. So that'll create a mesh and do some calc. I'll see you guys when we get a result or a fail. Okay, just while that is calculating, we're 34% through the simulation. Just going to examine this mesh. Here it is, attempt 1 refined imprint. Here's our local element, 2 millimeters, max size. That looks coarse as heck down through here. I don't think that matters too much, but I was trying to improve the calculation up in this zone, and if I turn off the seat post, inside there, I don't know, that looks bigger than 2 meters, 2 millimeters. That doesn't look very good at all. Let's turn off the seat tube. Same sort of issue. Doesn't really look like that's worked. So I'm expecting this calculation may not improve. Doesn't look like there's any real difference between this zone, which wasn't improved, and that zone that is. All right, stand by. I will create a new mesh. Okay, here we go. So this is the old mesh with a refinement of 2 millimeters on those faces. Let's load up the new one. That's this. So we've gone up from 19,000 nodes, 18.7 to 21,000 nodes. Increased the fineness. Did local element refinement of 0.5 millimeter. Let's rename this. 0.5 refinements. And if I turn off the C-tube, I don't know, that width there is like 1 millimeter or something, and these certainly look bigger than that. So I don't think this local element refinement is working in the way that I want. Let's have a look at some documentation. Standard mesher for CAE. I don't know what CAE is. Mesh. Sizing fineness, manual sizing. Small feature suppression, gap refinement factor. Meshed gap in mesh refinements. Here we go. Region refinement, volume custom sizing, local element size, surface custom sizing. Region refinement. Distance to the surface of the assigned volumes. Okay, so close to the surface we could give it more nodes potentially. Volume custom sizing. I don't think I want extra nodes through the part. I think I just want a lot more at the surface so that it can calculate better. Local element size. That's what I tried. Surface custom sizing. I haven't seen that option in. So if I go here to refinements, I don't have the option to choose a surface refinement. Certainly when I look at mesh quality, I don't know how to read this. I have no idea what that's doing. Doesn't look good though that the color scale like ends up here. What do you reckon that's doing? Beats me. Inflate boundary layer. Well, I think that's a CFD tool more than an FEA tool. Oh gosh. The sweep meshing refinement. None of those seem to apply. Oh, that looks better. Assembly 1 T-junction. That looks pretty refined. Sweep meshing refinement. This refinement only works for bodies that can be entirely swept. So in this tutorial that they have, non-linear structural analysis of a wheel, we've got meshing here. Where are we? Mesh setup. And this has refinements available. Sweep meshing, thin mesh refinement, using the standard meshing algorithm. Swept mesh for ground. I don't seem to have that thing. It says hexadecimal and prismatic elements which have the best numerical performance than the unstructured tetrahedrons. Well, mine seems to be unstructured tetrahedrons, so let's go looking harder. Let's go here, see what mesh generation options we have. Let's create a new mesh. We will call it blueprint other. Advanced settings. What do we got here? Small features, suppression. See, there's nothing here that allows me to do anything fancy. Let's see what's here. Maximum edge length, minimum edge length. Oh God, curvature. I don't know. Relative. I don't think I want it applied to the whole. Volume. But refinements just don't give us much option. Extrusion mesh refinement. Oh, here we go. So So we've got extrusion mesh refinement. I'm on the shim. I've selected 2 faces. I'll start faces, end faces. Oh God. I don't think this is going to work how I wanted it to. Maybe we can extrude from there to there. Don't think it's going to work. Let's see. It's failed, which makes sense because that shape can't sweep. May not be sweepable. Yes. Don't know. Think I'm going to give up for now. Let's check in on the simulation when it's done. All right, catch you guys soon. So it's the following day, and my simulation completed. Let's have a look. It took 109 minutes to process. Let's hit post-process results. Bends like a banana. Doesn't seem to split off and away from the seat post. Don't know why. I would have thought we'd see this stuff opening up. Yeah. Not sure. All right, well, I'll do some reading and bring you some future updates once I've got a little bit of progress. Catch you soon.